One of the most important mysteries concerning the sun is getting a little bit closer to being solved. The solar wind is a continuous flow of charged particles that flows away from the sun. Researchers have identified a plasma structure in the middle atmosphere of the sun that is complex, dynamic, and reminiscent of a web. This discovery suggests that the solar wind originates within this web. The discovery was made possible by the unusual studies of a difficult-to-access part of the sun, and it will clear the way for a NASA mission that is scheduled to launch the following year. Dan Seaton, a solar physicist at the Southwest Research Institute in Colorado and one of the study's authors, said in a statement that, quote, "We had no idea if it would work or what we would see," end quote. The statement was made in reference to the research. Quote, "The findings brought about a great deal of excitement. We now have access to high-quality measurements that entirely combine our previous observations of the sun and the heliosphere as a single unified system for the very first time." The corona is the name given to the uppermost layer of the sun's atmosphere, and it is normally only visible to humans during total solar eclipses, which occur when the moon completely blocks out most of the light from the sun. The middle corona, which is approximately 650,000 miles or 1 million kilometers above the surface of the sun, has been the region of the solar atmosphere that has received the least amount of attention. This is partly due to the fact that there haven't been any observations of the sun's corona at heights lower than 1.3 million miles or 2 million kilometers. In August of 2021, astronomers claimed that they had made the very first observations of the middle corona in wavelengths of severe ultraviolet light. The researchers discovered that the middle corona is the source of the structures identified in the solar wind by employing sophisticated instruments with expanding fields of view. This provided the first comprehensive look into the genesis of solar winds, providing a window into the process of comprehending an important phenomenon that affects every planet in the solar system. The term space weather refers to a collection of several ways in which the sun and its eruptions might have an effect on Earth. Solar wind is one type of space weather. Space weather has the potential to render electronic equipment useless, to compromise radio transmission, to disrupt the reception of mobile phones, and to disable power networks, as a result of the fact that scientists do not fully comprehend the precise mechanisms that are responsible for the ejection of solar winds and other forms of space weather. It is virtually impossible to predict such occurrences. Now, new observations in conjunction with data from more space missions and computer simulations have shown that there is a complex plasma network in the middle corona. Data collected during an observation campaign that lasted 1 full month and was carried out using the Solar Ultraviolet Imager or SUVI aboard the GOES-17 weather satellite operated by NOAA were analyzed by a group of researchers from across the world. Because of the satellite's wide range of view, it was able to collect photographs not only of the sun's core, but also of its flanks, giving scientists an unprecedented look at the development of the structure of this region. In a second statement, Seaton explained, quote, "We had the unique opportunity to use an instrument in an uncommon way to see a region that has not really been investigated. We had the chance to use an instrument in an unusual way to view a region that has not really been studied. Even while we didn't know for sure if it would work, we were confident that if it did, we'd come up with some very interesting finds." Using this information, the team was able to track a pair of coronal holes as they traveled over the solar disk. Coronal holes are areas on the sun that appear dark and signify locations where the sun's magnetic field is open to space and expelling material. When the coronal holes developed on the sun's east and west edges, the researchers noticed that the central corona had a highly structured coronal web that they dubbed the S-web. This intricate web is made up of magnetized plasma formations that is constantly engaging in conversation with one another and reconnecting. Researchers were able to observe this mechanism in action as it triggered solar wind streams higher than the coronal web. The findings from this study could potentially be relevant for a mission that is scheduled to launch from NASA in 2023 and is called the polarimeter to unify the corona and heliosphere, or punch. This mission will last for 2 years and will employ 3-dimensional imaging to take pictures of the sun's outer corona and the part of the solar system that is closest to the sun. The purpose of the mission is to gain a better understanding of how the corona generates solar wind. Now that we can image the sun's middle corona, we can connect what punch sees back to its origins and have a more complete view of how the solar wind interacts with the rest of the solar system. Seaton, who is now the Science Operations Center lead for Punch, said in the statement, "Before these discoveries, there were very few scientists who thought that it was possible to detect the middle corona to these distances in ultraviolet light. As a result of these investigations, an entirely new method for studying the corona on a global scale has become available." Thank you so much for watching the video. Don't miss out on our latest uploads. If you wish to stay up to date with the latest space updates and discoveries, hit the subscribe button, like the video, and turn on all notifications to see more of our latest videos in the future.